All right, so our purification has finished up a little while ago. So I've taken the liberty of already preparing our samples and so I guess treating them so that we can run our gel electrophoresis. So at the end of the purification, we had around 45 fractions collected. So if we wanted to test every single fraction, what we would have to do is test it on 3 gels. And even then, I guess we would lose 3 fractions. But instead, what we're going to do is we're only going to stick to using 1 gel for our anion exchange. And we're actually going to test every third fraction. We should still be able to get a good indication of where our beta gal is by doing this. So how I've prepped the samples is so I've taken about 8 microliters of a fraction, put it into an empty Eppendorf, and into that Eppendorf I've also added 5 or 8 microliters of this sample buffer. So I've done that for all 14 of our samples that we're going to test. So what in this sample buffer is the beta-mercaptoethanol, which is the reducing agent. And remember what that'll do is it'll break down the disulfide bonds in our protein. I place this on a heat block at 98 degrees Celsius for about 5 minutes. That way the heat can break all the hydrogen bonds, and now our samples have been treated and are ready to be analyzed through gel electrophoresis. So what I'm going to do is I've prepared a running buffer for the gel. This buffer contains our SDS, which is a very key component for the technique. Remember that the SDS, what it'll do is it'll help linearize the protein by coating it in a completely negative charge. So I'm just going to pour this into the gasket, making sure it goes completely over. Try to push off all the bubbles. And while I still have buffer in my cylinder, I'm actually going to remove the comb. I'm going to gently slide it up and quickly pull it out. This way, the wells should stay completely straight so that when we apply our sample, they'll be able to, I guess, sit nicely in the wells. So I'm just going to add the rest of my buffer. And we're now ready to run our gel. So the first thing I'm going to add is actually a ladder. So this will be our protein ladder that we'll use to kind of figure out how much, or I guess the size of the proteins. So I'm only going to add about 2 microliters of this ladder. Because it is a protein ladder, it does have proteins in it. So we keep it on ice to make sure that the proteins stay, I guess, relatively stable. So just going to take 2 microliters. I'm going to add it to the very first well. It's very hard to see this way. All right. So hopefully you can see the little blue line. That is our molecular ladder, or our protein ladder. So now I'm going to fill the rest of the wells with our actual samples. So I'm going to take about 8 microliters. And I'm going to just go down the wells, starting with the very first sample, which I believe is fraction 3. All right, so that's the very first well, and I'm just going to finish and go along the entire gel until I've added all my samples. All right. So I've added the 14 samples to the wells. They're a little hard to see. But yeah, you can kind of see the little blue faint wells. So now that all the samples have been added, I'm going to actually start the gel electrophoresis. I'm going to place the top, and we're going to run it at 210 volts for 45 minutes. So through this, now that we've applied the electric current, the the proteins are going to be pulled down towards the bottom of the gel, and at the end of the 45 minutes, we should be able to check, I guess, stain our gel and see where the proteins are relative to their size. All right, so here are the results for the anion exchange on the SCS Page gel. So you can see here up on the top, I have labeled all of the fraction numbers to kind of correlate to what band is for what fraction. So to begin, when we look at this gel, we see these darker bands. They're very thick compared to the rest of the bands on the gel. So this is a very good indication that these are the proteins that we wanted to, I guess, purify. These are the proteins this should be our beta-gal. But just to be 100% sure, we need to compare it to a ladder. So in our first well, here is the ladder that was ran alongside our fractions. And over to the left, I have provided you guys the ladder to use to kind of compare. So you can kind of see that the lines don't match up completely, but that is okay because you can see that on these ladders, there is a purple band. So these purple bands are so that we can kind of compare it to the gel and know exactly where we're looking in terms of the size. So luckily for us, we can see the first purple band here and the second purple band here. It's a little hard to see, but these are where the purple bands are. So up here, we know this should be 75. A little bit above that one, right here, very faded, should be 100. And right up here is 150 and 250. So we know that beta-gal is 114 kilodaltons big. So we should assume that beta-gal should be in between these two faded lines. And luckily for us, it is. So the band is pretty big, but we can kind of see that it's closer to the 100 side than it is to the 150. So one of the mistakes in this gel is that the gel had too much acrylamide, and because of that, we didn't get the gel to run farther down. Because technically we don't really care about all of this empty space. We want to see as much of it come down. So if the gel had less acrylamide, we would have gotten more of a separation, so we could better kind of compare the ladder to the actual sample. So when I do this again on the size, I'll try to make a better gel with slightly less acrylamide so that we can really compare these fractions.